I am Radhakrishna, mathematics teacher. We are going to continue our topic definite integrals. The first question, limit as n tends to infinity sigma of n ck by n power k by k plus 3, where k varies from 0 to n. This question appears to be from limits, but it is a question to be solved by definite integration. Let us see how. All of you are aware of one resultant binomial theorem, basic resultant binomial theorem, that is the expansion of 1 plus x whole power n when n is a positive integer is nc0 plus nc1 into x plus nc2 into x square and so on ncn into x power n. This is the basic binomial theorem. We can write this expansion as sigma k varies from 0 to n nck into x power k. Now, I want to use this binomial theorem here, but the problem is nck by n power k is okay, but 1 by k plus 3 is a problem. So, I am going to write that 1 by k plus 3 as a definite integral. 1 by k plus 3 can be expressed as integral 0 to 1 x power k plus 2. What is the integral of x power k plus 2? X power k plus 3 by k plus 3, and then substituting the limits 1 and 0, it will be 1 by k plus 3. Now, let us take this limit n tends to infinity sigma k varies from 0 to n nck by n power k into integral of x power k plus 2 dx between limits 0 and 1. Okay. Now, this integral is with respect to x. It is nothing to do with n and k. X is independent of n and k. So, we can write this integral here. It is equal to integral 0 to 1 limit n tends to infinity sigma k varies from 0 to n nck into x power k plus 2 by n power k dx, because integral is there, we have to write dx. Now, if I want to use this binomial theorem, the problem is if it is x power k, then x power k by n plus k, n power k can be written as x by n whole power k, we can use this result. So, there is power 2 extra. So, I will separate x square from this, I will write it as, I will write x power k plus 2 as x power k into x square. Okay. Now, this x is independent of n and k. So, these two are in terms of n and k. So, I can take out x square and write just after the integral. So, it is integral 0 to 1 x square into limit n tends to infinity sigma k varies from 0 to n nck into, what is the remaining? X by k by n power k is x by n whole power k dx. Now, apply this binomial theorem. This becomes 1 plus x by n whole power n. I will write the next step in the next page, or I will work out here. That is integral 0 to 1 x square into limit n tends to infinity this remaining is 1 plus x by n whole power n. Dx. Now, there is a standard limit, limit x tends to infinity 1 plus a by x whole power x is equal to e power a. This is a standard limit. All of you must be aware. So, in place of x we have n here, in place of a we have x here. So, what is this limit? E power x. So, this is equal to integral 0 to 1 x square into e power x dx. Now, how to integrate? If you integrate by parts 2 times, you will get e power x into x square minus 2x plus 2. You integrate and check between limits 0 and 1. Substitute 1 and 0 and take the difference, you will get the answer e minus 2. The calculation part you can complete. Let us move on to next question. Already we have solved this question. I just repeat the method. The definite integral will be in terms of alpha. After integrating with respect to x and substituting the limits, you will get the definite integral in terms of alpha. So, I will take it as I of alpha and differentiate I of alpha. I dash alpha will be integral 0 to 1 derivative of x power alpha minus 1 is x power alpha log x. Derivative of 1 is 0 by log x. This integral is with respect to x, but we are differentiating with respect to alpha. So, we will write the integral as it is and x also as it is, only we have to integrate with respect to differentiate with respect to alpha, keeping x as a constant. Now, into dx, log x cancels, integral x power alpha is x power alpha plus 1 by alpha plus 1. Substituting the limits, you will get 1 by alpha plus 1. After getting I dash alpha, I of alpha is equal to, what is the integral of 1 by alpha plus 1? Log mod alpha plus 1. But we have to write constant of integration because this is indefinite integration. Then how to find c? By putting some arbitrary value of alpha, we can calculate c. What value of alpha will you substitute? If you substitute alpha is equal to 2 or 3, you do not know what is I of alpha. But putting alpha is equal to 0, this is becoming 0, integral 0 to 1, 0 is 0. So, I will put x is equal to alpha is equal to 0. Then this becomes log 1 plus c. I of 0 is 0 and log 1 is 0. Therefore, c is 0. So, the value of I of alpha is log mod alpha plus 1. We have already solved this in the previous class. Next question. If x belongs to 0 to pi by 2, show that the sum of the integrals is independent of x. When the integrand is in terms of t and limits are in terms of x, here there is a mistake, it should be sin square x. Then after integrating with respect to t, then substituting limits sin square x and 0, you will get something in terms of x. Similarly, here also you will get something in terms of x. So, totally the sum of the integrals will be in terms of x. So, let us take it as f of x. Now, we have to show that it is independent of x, that means it is a constant. If it is constant, then its derivative should be 0. So, it will be sufficient to prove that f dash x is equal to 0, then f of x is a constant independent of x. So, let us find f dash x. f dash x is, how to differentiate this different integral, already we have discussed in the previous classes. Replace t by upper limit first, sin inverse of root sin square x. Then we have to multiply by the derivative of upper limit. What is the derivative of sin square x? 2 sin x cos x, that is sin 2x. Okay. And lower limit is 0, so substituting 0 and multiplying by the derivative of 0, it will be 0 only. Now coming to second integral, replace t by upper limit cos square x, it will be cos inverse of root cos square x, then multiply by the derivative of cos square x. Derivative of cos square x is minus sin 2x. Okay. Now root over sin square x is x, sin x. Sin inverse of sin x is x. So this will be x into sin 2x. Plus into minus is minus. Cos inverse of cos square x is also x. Root cos square x is cos x. Cos inverse of cos x is x. So it will be x sin 2x. Okay. In the interval 0 to pi by 2, cos inverse of cos x is x, not for all values of x. Okay. Now these two will cancel, f dash x is 0. Therefore, f of x is independent of x. F of x is a constant. Okay. Next, let f of x be a differentiable function such that f of x is equal to integral 0 to x e power t into sin of x minus t dt. I will write it. Now, if you want to differentiate this, here we are this integral is with respect to t, x is independent of t, x and t are independent to each other. Then how to differentiate this with respect to x? We cannot just treat t as a constant and differentiate just like previous question, because limit of t is also in terms of x. Usually when x and t are there, we treat them as independent variables or independent to each other, but here limit of t is x. So we cannot directly treat x t as a constant and differentiate with respect to x. So what we do is, first we apply property of definite integral. Integral 0 to x, you can replace t by x minus t, e power x minus t into sin of, replacing t by x minus t, it becomes sin t. Now we can take out e power x, it is e power x integral 0 to x e power minus t into sin t dt. Now this is one function and this is another function of x. Now differentiate, f dash x is equal to, see it is a product, so differentiate by UV rule. U dash means e power x into v, v means as it is integral 0 to x e power minus t into sin t dt plus u into v dash, u is e power x, v dash, differentiate this, replace x t by x e power minus x into sin x, then multiply by the derivative of upper limit 1 into 1. Lower limit is constant, so no need to subtract anything. Now, what is this? This is again f of x. So, I will write it as f of x plus what is the second? These two will cancel, you will get sin x. And g of x is f double dash x minus f x. So, again differentiate, you will get f double dash x is equal to f dash x plus cos x, derivative of sin x is cos x. Now, substitute f dash x here, substitute f dash x there, it becomes f dash x, sorry, you will get f of x plus sin x plus cos x. Then g of x is equal to, g of x is f double dash x minus f x. So, this minus this, it will be sin x plus cos x. Then what is the range of g of x? All of you know that range of sin x plus cos x is minus root 2 to plus root 2. Closed interval minus root 2 to plus root 2. Okay. Next question. Yeah, now we are going to discuss some more theory in definite integration. One is intermediate value theorem. Intermediate value theorem is, if a function is continuous in the interval a to b such that integral a to b f of x dx is 0, then there exists at least one c in the open interval a to b such that f of c is equal to 0. Let us see how. Let these two be x axis and y axis. Take an interval a to b. This is x is equal to a, this is x is equal to b. Function is continuous from a to b means you take f of a somewhere, g of b somewhere on this line, and those two points will be connected by a continuous curve without any break. Then suppose the graph is completely above the x axis, then what happens? If the graph is completely above the x axis, then if you integrate from a to b, you will get sum of the values of the function. Thus, definite integral is nothing but sum of all values of f of x. Since every value of f of x is positive, the sum cannot be equal to 0. That means graph cannot be completely above the x axis. Now, if you take the graph of f of x completely below the x axis like this, then the values of f of x in the interval a to b are negative everywhere. Then sum of all the negative values will be negative. So, this definite integral is negative, not equal to 0. So, when can you get 0? You can easily realize that the graph should have some part above the x axis, some part below the x axis. Therefore, the graph, if the integral is 0 and function is continuous, then some part of the graph should be above the x axis, some part should be below the x axis like this. Then only integral in this interval is negative, integral in this interval is positive, again negative, positive, negative. Then if the negative values and positive values are cancelled, then you may get 0. That is the only possibility. So, what can you say? In the interval a to b, at least one point the graph should intersect the x-axis, because graph should be some part above the x-axis, some part below the x-axis. Graph of f of x must intersect the x-axis. At that point f of x will become 0. So, there exists at least one c in the open interval a to b c where f of c is equal to 0 at the point of intersection with the x-axis. Or the same statement can be written as there exists at least one root of the equation f of x is equal to 0 in the interval a to b. In this example there are 4 roots. In some other example, in the whole interval a to b, graph may intersect only once, so that this area and this area are cancelled. Okay. So, that is called intermediate value theorem. Now, next theorem is mean value theorem. Mean value theorem is, if a function f of x is continuous in the closed interval a to b, then there exists at least one c in the open interval a to b such that the definite integral is equal to b minus a into f of c. Let us see how. In the interval a to b, suppose the graph of a function is like this. We have already discussed in the beginning of this chapter that definite integral a to b f of x dx is nothing but summation of values of f of x multiplied by small width dx, that is sum of the elementary areas. Okay. And sum of the values of f of x in the interval a to b is integral a to b, sum of the values of f of x in the interval a to b is integral a to b f of x dx. What is the average value of f of x in this interval? We have to divide by the number of values. Already we have discussed this point, because here number of values of f of x added in the sum is infinite. So, instead of number of values, we take length of the interval. What is the length of the interval? B minus a. If we divide this by b minus a, what will we get? The average value of f of x in the interval a to b. The average value is also known as mean value. So, this is the average value of f of x in this interval. Now, average always lies in the middle of the values of f of x. It lies in the middle of the interval from minimum to maximum of f of x. So, suppose average value lies here. Function is continuous. So, at this point the function attains the average value. It may attain the average value once or more than once, but without touching the average value, you cannot draw the graph. So, at some point, say it is c, this value will be equal to f of c. There will be at least one point c such that f of c is equal to integral a to b f of x by b minus a. Cross multiplying by b minus a, we get integral a to b f of x dx will be equal to b minus a into f of c for at least one c in the interval a to b. This is called mean value theorem. Next, inequalities. First one, integral a to b f of x dx whole mod will be less than or equal to integral a to b mod f of x dx. Suppose the graph is completely above the x axis, then f of x is positive. So, integral f of x mod f of x dx is f of x only, and the sum of the values of the function, this is sum of all values of f of x in this interval, that is also positive. So, there is no need of writing the modulus, both are equal when the graph is completely above the x-axis. When the graph is completely below the x-axis, if the graph is suppose like this in the interval a to b, then what happens? F of x is negative everywhere in this interval, but in the RHS if you take mod, all these negative values become positive and you are adding the positive values. So, RHS will be definitely a positive number, and that will be equal to the area of this curve, area under this curve formed by the curve and x axis between x is equal to a and x is equal to b. And in the LHS, without mod you will get some of the negative values negative. If you take whole mod, it becomes positive and equal to this area again. So, these two are equal. When the curve is completely above the x-axis or completely below the x-axis, LHS and RHS are equal. But when the curve is some part above the x-axis, some part below the x-axis in the interval a to b, in the interval a to b, suppose the graph is like this. In this case, if you take LHS, so for example this is 3, this is 2, this is 4, this is 1. What will be the definite integral from a to b? This definite integral in this interval will be minus 3. This definite integral in this interval will be plus 2. Similarly, minus 4 plus 1. Then you are getting minus 7 plus 3 minus 4. If you integrate from a to b, definite integral will be minus 4. After calculating the definite integral, if you take mod, you will get plus 4. But in the RHS, you are taking modulus for f of x, then adding. That means in this interval, if you take mod and add, you will get plus 3 only. This is plus 2 only. Next is by taking mod, all these negative values become positive. This definite integral will be plus 4. Then plus 3 plus 2 plus 4 plus 1, what happens? You will get 10. So, RHS is greater than LHS. Okay. So, when the graph is completely above the x-axis or completely below the x-axis, both are equal. Otherwise, if some part is below the x-axis, some part is above the x-axis, this will be strictly less than this. So, you can easily understand this inequality. Next is, if f of x is less than or equal to g of x for all x in the interval a to b, then integral a to b f of x dx is less than or equal to integral a to b g of x dx. This is also a very easy concept to understand. In the interval a to b, suppose the graph of f of x is like this, graph of g of x is like this. This is y is equal to f of x, this is y is equal to g of x. This is x is equal to a, this is x is equal to b. If you integrate f of x, what you will get? Sum of the values of f of x in this interval. And integral a to b f of x g of x dx is sum of the values of g of x. Everywhere f of x is less than g of x. So, sum of the values of f of x will be less than sum of the values of g of x, easily understandable. Okay. Even if f of x and g of x are below the x axis, that does not matter, same thing will be true. Next point, if small m and capital M are the absolute minimum and absolute maximum values of f of x in the interval a to b, then b minus a into small m is less than or equal to integral a to b f of x dx less than or equal to b minus a into capital M. I will take the interval like this, x is equal to a to x is equal to b. I will draw the graph of f of x like this. Now, what is the absolute minimum of this function in this interval? It is here. This is absolute minimum, and where is absolute maximum? It is here. Now, integral a to b f of x dx is nothing but this area. This shaded area with black color is the value of the definite integral, because I have taken the curve completely above the x-axis. Now, sometimes it is not possible to integrate the function and get the area. Then you can estimate the interval in which it lies. At minimum point, this is absolute minimum. This is local minimum, this is absolute minimum. That is why I said absolute minimum, similarly absolute maximum. At absolute minimum, if you draw a horizontal line, and similarly at absolute maximum, you can easily say that area of the shaded region, that is integral a to b f of x dx, lies between area of this small rectangle and area of the big rectangle. What is the area of the small rectangle? This is small m and this is capital M. Absolute minimum is small m. Then this area is what? This height is small m, this width is b minus a. So, area of the small rectangle is b minus a into small m. It is less than, actually it is less than this shaded part, integral a to b f of x dx is again less than capital M, this height, into b minus a, area of the big rectangle. Understood? Okay. But why is it given equality also? If the graph is a straight line parallel to x-axis, then all are equal. That is why equality is also given. So, sometimes if it is not possible to find the integral, then we can estimate its interval using this inequality, okay. Or sometimes we can calculate its interval of the integral by using this. Suppose you want this integral a to b f of x dx, but f of x is not an integrable function, is it not? If f of x is not integrable function, then if you know that f of x is less than g of x, where g of x is integrable, then using this you can calculate this and we can get some upper limit of integral a to b f of x dx, okay. So, using this point and this point, we can estimate the interval of the definite integral. Next point, Cauchy's inequality. All of you are aware of Cauchy's inequality in real numbers. In real numbers, if a1, a2, a3 and so on, an is a set of real numbers, b1, b2, b3 and so on, bn is another set of real numbers. Cauchy's inequality is sigma ai bi whole square, where I varies from 1 to n, is less than or equal to sigma ai square, where I varies from 1 to n, into sigma bi square. All of you are aware of this. Condition for equality is a1 by b1 is equal to a2 by b2 is equal to a3 by b3 and so on. Okay. Now, the meaning of sigma and integral is same. Sigma is used for discrete summation. Here I is a discrete variable, it takes only integral values, but sigma is a continuous variable. This integral, in integration, x is a continuous variable. Okay. So, for continuous summation we use integral, for discrete summation we use sigma. Here instead of ai, a1, a2, a3 and so on ai, I will take function f of x. Instead of bi's, I will take function g of x. Okay. Now, I am adding the values of f of x, the values of the products f of x into g of x in the interval a to b, that is same as sigma ai into bi whole square. It is always less than or equal to sigma ai square, means integral f of x whole square into integral g of x whole square in the interval a to b. Okay. This is called Cauchy's inequality, where the equality occurs when here a1 by b1 is equal to a2 by b2 is equal and so on, means ai by bi is a constant. So, here f of x by g of x is a constant, then only equality occurs. Now, let us solve problems. First problem, integral 0 to 1 x square minus 2 plus alpha into x plus 2 alpha into e power x square dx is equal to 0. Then what is the interval of alpha? First, you can write this quadratic expression as a product. Integral 0 to 1, factorize, what you will get, x minus alpha into x minus 2 into e power x square dx. Now, x minus alpha into x minus 2, that is quadratic. A quadratic function is continuous everywhere. Any polynomial function is a continuous function, and e power x square is also a continuous function. So, their product is continuous function. So, this whole integral is this function is continuous, but integral 0 to 1 f of x dx is 0. Now, by intermediate value theorem, the equation x minus alpha into x minus 2 into e power x square is equal to 0 should have at least one root in open interval 0 to 1 by intermediate value theorem. What are the roots of this equation? X is equal to alpha or 2. E power x square is never 0. Graph of e power x square will be strictly above the x axis. So, the roots are alpha and 2. 2 does not lie in this interval. Therefore, alpha should lie in the interval 0 to 1. Therefore, 0 is less than alpha less than 1. Answer is option B. Okay. Next question. If integral 0 to 1 plus sine power 4x into ax square plus bx plus c dx is equal to integral 0 to 2 1 plus sine square x bracket in 1 plus sine power 4x into ax square plus bx plus c dx, then the equation ax square plus bx plus c is equal to 0 will have at least one root in the interval. Options are given. This is open 1 to 2. Let us take this function as f of x. What is the given condition? Integral 0 to 1 f of x dx is equal to, what is the RHS? Integral 0 to 2 f of x dx. We can write the RHS as integral 0 to 1 f of x dx plus integral 1 to 2 f of x dx. Then this will cancel. Then integral 1 to 2 f of x dx is 0. Is f of x continuous? 1 plus sine power 4x is continuous function because sine function is continuous. Quadratic function is continuous. So, their product is continuous function. So, since f of x is continuous and this integral is 0, f of x is equal to 0 should have at least one root in the interval 1 to 2. What is f of x is equal to 0? 1 plus sine power 4x into ax square plus bx plus c is equal to 0 should have at least one root in the interval 1 to 2. But this is never 0. Therefore, the equation ax square plus bx plus c is equal to 0 should have at least one root in the interval 1 to 2. Option C is correct. Next question. Show that 1 is less than integral 0 to pi by 2 sin x by x dx less than pi by 2. We prove this by using the inequalities discussed before starting the problems. Let us take the function f of x is equal to sin x by x and draw the graph of sin x in the interval 0 to pi by 2. We know that it is not defined, f of x is not defined at x is equal to 0. So, at 0 there is no point, but limit as x tends to 0 f of x, that is sin x by x is 1. X tends to 0 means we have to take 0 plus. So, let us take 1 here. The graph will be approaching this point from the right side of 0. From there, what will be the graph? To draw the remaining graph, we have to differentiate f of x and see whether it is increasing or decreasing. F dash x is equal to derivative of u by v is u dash v, that is x cos x minus u v dash, that is sin x by v square. Now, taking cos x common, cos x into x minus tan x by x square. Okay. Now, in the interval 0 to pi by 2, cos x is positive, x square is positive. What about x minus tan x? All of you must be aware of one standard inequality in the interval 0 to pi by 2, sin x is less than x less than tan x. You draw the graph of tan x, graphs of these three in the interval 0 to pi by 2 and observe. You can know that sin x is less than x less than tan x. So, x is less than tan x in the interval 0 to pi by 2. So, this is positive, but this is negative. So, f dash x is less than 0, positive into positive is negative. Then f of x must be decreasing function. So, from 0 to pi by 2 it decreases. So, I will draw something like this. At pi by 2, what is the value of the function f of pi by 2? Sin pi by 2 by pi by 2 is 2 by pi. So, this is 2 by pi. This is the graph of f of x. Now, even if it is not defined at 0, we can calculate this integral, because only one hairline is missing, and also every definite integral is a limiting value. Now, shade the area. That definite integral is equal to area of the shaded region. Now, what is the minimum value of absolute minimum of this function in the given interval? It is at pi by 2. This is absolute minimum. Where is absolute maximum? Here, 1. Draw a big rectangle and small rectangle. This integral lies between the area of the small rectangle and area of the big rectangle. Therefore, what is the area of the small rectangle? This is pi by 2, this is 2 by pi. So, pi by 2 into 2 by pi less than integral 0 to pi by 2 sin x by x dx is less than, what is the area of the big rectangle? This is pi by 2, this is 1. So, pi by 2 into 1. This is 1 less than this less than pi by 2, it is proved. Okay. Next question. Show that pi by 6 is less than integral 0 to 1 dx by root over 4 minus x square minus x cube less than pi by 4 root 2. The function which is to be integrated is 1 by root over 4 minus x square minus x cube. Here no one can integrate this function. When cube root x cube is there inside the square root, no one can integrate this question, but we can estimate its interval. How? Since we cannot integrate this, we will write an inequality such that some function is less than this less than some function, so that this function and this function should be integrable. When is it integrable? When quadratic term is there under this root, it is integrable. So, here I want to write a function which is smaller than this. In the interval 0 to 1, x cube lies between 0 and 1. If I remove x cube, what happens? The denominator increases, because you are removing minus x cube. When the denominator increases, value decreases, total value decreases. So, if I remove x cube, I can write 1 by root over 4 minus x square is less than this. Now, you see this can be integrated. Now, this is less than something. So, here I have to write something which is integrable. Now, we have to write some function which is larger than this. Then I have to decrease the denominator. In the interval 0 to 1, when the power of x increases, the value decreases. So, x cube is less than x square in the interval 0 to 1. So, minus x cube is greater than minus x square. So, if I replace x cube by x square, the whole value becomes larger. Therefore, this is less than root of 1 by root over 4 minus x square minus 2x square. Okay. And this is integrable because it is 1 by square root of a quadratic. Now, integrate on both sides. Integral 1 by root 4 minus x square. This inequality is true for all x belonging to 0 to 1. Integral 0 to 1, 1 by root 4 minus x square dx is less than integral 0 to 1, 1 by root over 4 minus x square minus x cube dx is less than integral 0 to 1, 1 by root 4 minus 2x square dx. What is the integral of this? Integral 1 by root over a square minus x square is sin inverse x by a. Here sin inverse x by a means 2 between limits 0 and 1 is less than, I will take this as I, the middle function, middle integral, is less than, if you take root 2 common from denominator, you will get 1 by root 2 into, what is the remaining? If you take root 2 common in the denominator, it becomes root 2 into root over 2 minus x square dx. What is the integral of 1 by root over 2 minus x square? Sin inverse x by root 2 between limits 0 and 1. Now substituting the limits, sin inverse 1 by 2 is pi by 6, sin inverse 0 is 0, so it is pi by 6 less than I less than 1 by root 2 into, substituting 1, sin inverse 1 by root 2 is pi by 4, so pi by 4 root 2 you will get. Substituting 0, it will be 0. So that is proved. Next, if S is equal to integral 0 to 1 e power minus x square dx, then again we have to estimate the value of S. E power x minus x square or e power x square can never be integrated. E power x square can be integrated only when its derivative of x square is 2x or x is present along with the function e power minus x square. So no one can integrate e power minus x square. So this kind of integrals can be estimated using the inequalities discussed. Now let us first draw the graph of e power minus x square. To draw the graph, first you check its derivative. What is the derivative of e power minus x square? Derivative of e power minus x square is e power minus x square into minus 2x. Okay. Then if x is positive, it is negative. In the interval 0 to 1, it is negative because e power minus x square is always positive. So in the given interval 0 to 1, e power minus x square is a decreasing function. Let us draw the graph. At 0, what is the value of the function? E power minus 0 is 1. At 1, what is the value of the function? E power minus 1 means 1 by e. So I will draw some decreasing function like this. Now the value of S will be equal to area under this curve. Between x is equal to 0 and x is equal to 1 formed with x axis. Now first this area, it is greater than, this area is greater than area of the small rectangle. At a minimum point is 1 by e, because the function is strictly decreasing, minimum point occurs at the end point. At minimum point draw a horizontal line at absolute minimum. Then the total area is greater than area of the small rectangle. What is the area of the small rectangle? This length is 1, this height is 1 by e. So 1 into 1 by e, 1 by e. So option A is correct. Next, option B. In option B, let us, again it is greater than, given it is greater than. Okay. So taking S is less than area of the big rectangle, you won't get it. So what we do is, we will write some inequality. Integral 0 to 1 e power minus x square dx. We cannot evaluate, but we want to estimate it as it is greater than something. Then, as we have discussed, we will write a function which is smaller than this and integrable. In the interval 0 to 1, which is smaller among x square and x? Obviously, x square is less than x in the interval 0 to 1. So minus x square will be greater than minus x. If you multiply by minus sign, inequality will change. Then taking base e, e power minus x square is greater than e power minus x. It is true in the interval 0 to 1 only. So in the interval 0 to 1, I will write e power minus x square is greater than minus e power minus x and integrate on both sides. Now you will be able to calculate this integral. What is the integral of e power minus x? E power minus x by minus 1. Substitute the limits 0 and 1. Substituting 1, you will get minus 1 by e. Substituting 0, you will get 1. So we will get 1 minus 1 by e. S is greater than 1 minus 1 by e. Option B is correct. Now, to check options C and D. This was a previous JEE question asked in more than one correct answer type questions. So we are checking the remaining options also. After getting the correct answer as A, since it is multiple correct answer type question, we are verifying the options B, C, D also. Now to verify the options C and D, you observe the options. We have got numbers like 1 by root e and 1 by root 2. Okay. 1 by root e means for what value of x you will get 1 by root e? X is equal to 1 by root 2. For x is equal to 1 by root 2, you are getting the number 1 by root 2. Sorry, for x is equal to 1 by root 2, the value of the function becomes 1 by root e. That means this time we have to divide this total area into two parts. Let us break this interval into two parts, 0 to 1 by root 2 and 1 by root 2 to 1. I have to write less than in both the cases. For less than, what we will do, draw a bigger rectangle. In this interval, this area of the shaded part is less than area of the big rectangle. Similarly, in this interval, this area of the shaded part is less than area of the bigger rectangle. What is the area of this bigger rectangle? Tell. This is 1 by root 2. Okay. What is the side 1? So the area of this big rectangle is 1 by root 2 plus area of this bigger rectangle is, what is this difference? 1 minus 1 by root 2 into what is this height? At x is equal to 1 by root 2, what is this height? 1 by root e. So this height is also 1 by root e. So this into 1 by root e. This area of the shaded part is less than the area of the big rectangle plus area of this big rectangle. So option D is correct. How to check option C? You can easily observe that this is smaller than 1 by E and smaller than 1 minus 1 by E. Already we have proved that S is greater than this or greater than this. So, if you get S is less than a number which is less than 1 by E, then it is false. So, this is the wrong answer. So, answer is A, B, D. Next question. It is known that f of x is odd function in minus t by 2 to t by 2 and periodic with period t, capital T. Then prove that integral 0 to x f of t dt is periodic with period capital T. F is periodic with period capital T. We have to prove that integral of f is also periodic with period t. Let us take integral 0 to x f of t dt as g of x. Now, we need to prove that g of x is periodic with period capital T. So, what is the property of periodic function? If we can prove that g of t plus x is equal to g of x, then g of for all x, then g of x is a periodic function with period capital T. So, I will take g of t plus x. G of t plus x is integral 0 to t plus x f of t dt. I have to express it as, I have to prove that it is f of x, sorry, g of x. Now, we can write this definite integral as a sum of two definite integrals, integral 0 to x f of t dt plus x to x plus t. F of x dx. This is nothing but g of x. Plus f of x is periodic with period capital T. You have a property of periodic function. If f of x is periodic function with period capital T and n is an integer, this is equal to n integral 0 to t f of x dx. It is independent of a. Here we can write t as t into 1 and applying that property, this will be equal to integral 0 to capital T f of t dt. It is f of t. F of t dt. Okay. Now, if we can prove that this is 0, that is enough. So, I am going to prove that this integral is 0. I will do it separately. Integral 0 to t f of x dx. We can write it as 0 to t by 2 f of t dt plus t by 2 to t f of t dt. Okay. In the second integral, put t minus t by 2 is equal to some y. Then dt is equal to dy, write the first integral as it is, and second integral will be plus integral, what will be the new limits, 0 to t by 2. I think we should write t minus capital T is equal to y. Then if small t is equal to t by 2, y will be equal to minus t by 2. If small t is equal to capital T, y will be 0. Then it will become f of t plus y dy. Since f is periodic with period capital T, it becomes integral minus t by 2 to 0 f of y dy. First one is integral 0 to t by 2 f of t dt. Now, since f is odd function, you prove that this is minus of this, then these two will cancel. If you want to prove that this is equal to minus of this, put y is equal to minus z, then you will get this is equal to minus of this. These two will cancel and you will get 0. If this is 0, g of t plus x is equal to g of x, and g of x is periodic with period capital T. Okay. So, now time is up, we are going to conclude this session. So, we are going to meet in the next class.